All right, in this video we are going to learn a sort of sophisticated rule here for how roots operate in polynomial equations. And I have a few examples over here on the side to show you guys. My first graph that I'm making, you can see the equation is written right here. I have x plus 5, x plus 2, x minus 1. And it's no surprise if you look at the picture, x plus 5, the graph hits at x equals negative 5. My x plus 2 makes x equals negative 2. And my x minus 1 equals x equals positive 1. Each of these x-intercepts in this problem, if you look at the picture, what the picture does is it kind of passes right through each of those roots. This is the normal situation here, where the graph just cuts through each of my solutions. You don't have to write this picture down. I'm going to show you some smaller examples in a second that I'll have you copy. This is just looking right now and observing what's going on. So that is our basic default situation. What I'm going to do now is switch over to this graph, my second equation right here, which is in blue. This time, if you look at my actual equation, what I did is I made 2 of the x plus 5s. That means the answer of x equals negative 5 actually repeats twice. The third answer of x equals positive 1, that's just right here, and that happens one time. So if you look at this answer, this guy is doing what all the other ones do, where the graph just slices or cuts right through that solution. But over here, at negative 5, the answer that repeats, well, actually what's going on now is my graph sort of bounces off of that answer and makes almost like a little parabola within our graph. So repeated roots, if a root repeats twice, what you'll see is you'll see the picture bounce off of that x-intercept like this, instead of slice through it like this. And I have one more example of that, and it's the third equation written down. If you look at my green graph, this time the root repeats 3 times. It's x equals negative 5 for all of these. And at that point, it does go to the other side. It doesn't bounce off like this, like it would do if it was repeated twice. But actually what happens is it does like a weird wiggle or swerve move right here, instead of just passing right on through like that. So if you have a root that repeats 3 times, you'll see a little swerve going on in the picture before it crosses over. This is kind of complicated, and there's several, it's just kind of learning patterns, basically. I have a few quick pictures to show you guys what's going on. So these pictures, I do want you guys to have kind of copied down. If I look at this first picture, each of these roots only it crosses through nicely. So each of these roots in the first picture only occur once. So each root only occurs once. So that would mean when I write my equation, like this x equals negative 2, for example, I would only have to write down x plus 2 the one time. Then I have x minus 1. Then I have x minus 4 for my parentheses. That one is your basic example. Each one passes on through. If you look at this second picture, though, this answer at positive 3, it bounces back and doesn't cross over to the other side of the axis here. That answer is going to repeat twice. So when I make my equation this time, that x minus 3 is actually going to happen 2 times, and then I have an x minus 5 as well from this guy that only happens once. If you go on to this third picture here, this answer, it does like a little swerve as it crosses over. This answer is actually going to repeat 3 times. So what I would have for this, it's x equals 4. So there would be x minus 4 written down 3 times. My last picture, I'm not going to make an equation for it, but I'm just going to practice again with what's going on. This x-intercept bounces back. Since it bounces back, This is going to be 2 times. These are not x-intercepts. The only other one is over here where it does like a little swerve. So that answer repeats 3 times. It's going to take some practice to get used to these rules, but if you look at the picture where it hits the x-axis, you can get a sense for what the equation is going to look like.